In this video, we're going to be writing a polynomial functions when we are given the roots. So we have to remember that the name roots, this definition of roots, so this here is the same thing as zeros. That's where y equals 0. That's our x-intercept. So basically all these are what x equals when y is 0. The other word that we need to recognize is this word quartic. So a quartic means that we have a fourth degree polynomial, which means it's going to be something x to the fourth. So that means that we should have a total of 4 roots. They've only given us 3, but that's really not a problem. So before I talk about that, let's go ahead and write down what our zeros are. So I have the 0, x equals negative 3i. I'm going to leave a space for a reason, because remember I need 4 roots, and it has to do with this imaginary number. I also have x equals 6, and I also have x equals negative 5. So those are my zeros. Now the thing that I need to keep in mind has to do with imaginary numbers. So remember that imaginary numbers always come in pairs. So that means there has to be 2 of them. So if we remember from our quadratic formula, a quick review on that, our quadratic formula is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a, that when we got an imaginary number, it came from this square root right here. So I'm going to go ahead and highlight this square root, because this is in our quadratic formula where we get, remember we simplified, that's where we got our imaginary numbers. Look what's right in front of that square root. We have this plus or minus whatever happened at the end. So here I have the minus, I just need the plus part. So that means I need to know that whenever I see an imaginary number, its pair will be the opposite sign. So this is my missing 0. They didn't give me that one. Okay, so this means that we need to turn our zeros into factors. So let's start with, we're going to add 3i to both sides, so that gives me x plus 3i. That's one factor. And here I'm going to subtract 3i, so that gives me x minus 3i. That's another factor. Subtract 6 from both sides, so that gives me x minus 6. That's another factor. Add 5 to both sides of the equals, that gives me x plus 5. So technically I should write equals 0, equals 0, equals 0, equals 0. But that's okay. So I actually want to I understand that that's there. I want to actually write the polynomial. So I like to multiply like things together. So these two I'll multiply together first. And then I'll multiply these two things together. And then the products of those two I will multiply together. So let's go ahead. I'm going to use the box method just because this can get a little confusing with our i's. So remember, I is a number. I is the square root of negative 1. So that's going to be important when we do this. So if I multiply x plus 3i and x minus 3i. X times x gives me x squared. 3i times x gives me 3ix. X times negative 3i gives me negative 3ix. And 3i times negative 3i gives me negative 9i squared. This is going to be important right here. So this is putting some things from a previous unit together. When we look at the diagonal, the peanut of math right here, those are our like terms. So let's go ahead and take everything out of the box. You haven't finished until it's out of the box. Nothing can be added to x squared, so that's just x squared. Negative 3ix plus 3ix gives me 0. So then I'm left with negative 9i squared. Well, let's talk about this I squared right here. So remember, if I is the square root of negative 1, if I square I, that means then that I squared is, well, remember, the square undoes the square root. That makes that just go away. It undoes it. So I'm left with negative 1. So I squared is negative 1. That means this can be rewritten to be x squared minus 9 times negative 1, because these are equivalent. So then that gives me, for this factor, x squared plus 9. So that's what x plus 3i times x minus 3i becomes. Let's go ahead and multiply these two binomials together. I'm going to do this by distributing. Some people call it FOIL, but it's really just distributing. So x times x gives me x squared. X times 5 gives me a plus 5x. And then I have negative 6 times x. That gives me negative 6x. And negative 6 times 5, that gives me a negative 30. I have like terms right here, so I need to combine those. My first term is x squared. 5x minus 6x gives me minus x. And then I have negative 30. So remember that this was the product of these two binomials. This is the product of these two binomials. Now I have to multiply all these two together. So again, I'm going to use the box rather than distributing because it's just cleaner. So some of you make little teeny tiny boxes. Don't do that. You want to be able to see your numbers. Again, notice I wrote down what my expressions were before I drew the box, and I allowed them to be my column and row headers. So now we're going to multiply the outside. X squared times x squared gives me x to the 4th. Negative x times x squared gives me negative x cubed. Negative 30 times x squared gives me negative 30 x squared. X squared times 9 gives me 9x squared. Negative x times 9 gives me negative 9x. And negative 30 times 9 gives me negative 270. So the peanut of math is kind of funky on this one, so we're going to look at the diagonals. So this one and that one are like terms right there. So let's go ahead and take this out, and then we're done. So my first term is x to the 4th. My next term is negative x cubed. So now I have to add 9x squared to negative 30x squared, and that gives me negative 21x squared. And then I have a negative 9x, and then I have negative 270. So this is my polynomial function. I'll just call it p of x, which is the same thing as y. So given the three roots they gave me, one of which was imaginary, I was able to write a quartic polynomial. As we can see, that's quartic. And so if I were to graph this in my calculator, I will find that I have these two real roots, and then I would have to do some math, and I would find then that I would get these two factors as well.